In the previous video, we saw that if free electrons are not directed, they can move anywhere. But if we give them a direction and a proper push to move, they start moving in a coordinated fashion. And this coordinated flow of electron is what we call as current. But the question remains, how can we make electrons move? How to create continuous flow of electrons, and how to maintain that continuous flow of electrons? Well, I'll answer these questions in this video in the easiest way possible. So to get the answers and the concept of voltage, you need to watch the video. Question number 1. How can we make electrons move? We all are familiar with such toy. If you push this car backward, it gets charged and now it will move forward once we release our hand. At this position, car is standstill. Let's say now I want to charge this car, and to do so, I'll drag the car backward from the start line to end line 1. Now listen carefully. To charge this car, I have to push it back, and to push it back, I need to apply some energy to it. Or I can say, I have to do some work to charge the car. Now, once I have done some work, that work must be stored in the car. Now, if I remove my finger from the car, the stored energy will be released and the car will move. So the moral of the story is we have to do some work to charge the car, and that work is stored in the car. And this stored energy in the car is what we call potential energy. Why potential? Because the energy has potential or ability to move the car, and hence it is called as potential energy. Without this potential energy, car cannot move and it will remain standstill if we do not charge it. After charging the car has capacity to do some work, and this capacity is what we call electric potential. Same is the case with electrons. To charge electrons, we have to do some work, and this work is stored in the electron as potential energy. These charged electrons now has capacity to perform some work, and that is what we call electric potential. The capacity of the charged body to do work is what we call as electric potential. So what was the question? How can we make electrons move? And the answer is electric potential. Amount of electric potential depends on how much we charge the body. For example, in our previous case, we charged the car up to end line 1. So it has got some, let's say, X electric potential. But now we will charge it up to end line 2. And to do so, we have to do some extra work as compared to previous case. And of course, that will result in more electric potential, and now that would be X plus Y, whereas Y is the distance between end line 1 and end line 2. So obviously, work done to charge a body to 1 coulomb would be the measure of its electric potential. Electric potential is denoted by letter V. Electric potential, or V, is equals to work done by charge, or W by Q in short. We measure work done in joules and charge in coulomb. Therefore, unit of electric potential will be joules per coulomb or volt. So if we did work of 1 joule to charge a body to 1 coulomb, then the electric potential will be W by Q, that is 1 by 1 equals to 1 volt. So the conclusion is a body is said to have electric potential of 1 volt if 1 joule of work is done to charge that body to 1 coulomb. Let's read that again. A body is said to have electric potential of 1 volt if 1 joule of work is done to charge that body to 1 coulomb. So we did 1 joule of work to charge the car to 1 coulomb, and hence the car will have electric potential of 1 volt. If someone say the body has electric potential of 5 volts, then what does that mean? It means 5 joules of work has been done to charge that body to 1 coulomb. Or we can say in other words that every coulomb of charge has an energy of 5 joules. The more joules per coulomb, more is the electric potential. Question number 2. How to create continuous flow of electrons? Now we just saw that we need electric potential to move electrons, but how can we make electrons move continuously? Let's check that out. To understand how to create continuous flow of electrons, let's do an experiment. Here I have two bottles filled with water. As you can see, bottle A is filled with water above the center line of the bottle, and in bottle B, water is filled below center line. In technical language, I would say bottle A is having electric potential of 10 volt and bottle B is having electric potential of 4 volts. Now, if I connect a small pipe between these two bottles, then what will happen? Let's check that out. So as you can see, after connecting a pipe between these two bottles, water has started flowing from bottle A to bottle B. That is, from higher potential to lower potential. Water will now continue to flow until water level of both the bottles become equal. Here you can see water is not flowing as the level of both the bottles are now equal. So we have arrived at two very important conclusions. Conclusion number 1, water will only flow from one position to another if there is a difference in water level of two bottles. Conclusion number 2, if the water level of both the bottles are same, water will not flow. And this difference in the water level of the two bottles is what we call potential difference. In the same way as bottles and water, current will only flow if there is a potential difference exist between 2 points. Please note, here I am referring to 2 points and not to a single point. This question is asked many times, that why potential difference is always referred between 2 points, and now you have the answer. To keep this in mind, you just have to remember the example of 2 bottles. So like water, current will only flow from one point to another only if there is a potential difference between those 2 points. No potential difference, no current or continuous flow of electrons. Mark that sentence permanently in your mind. No potential difference, no current. Potential difference is sometimes also called as voltage. So our second question was how to create continuous flow of electrons, and the answer is potential difference or voltage. Of course, the unit of potential difference will be volt. And we can say potential difference between 2 points is 1 volt if 1 joule of work is done or released to transfer the charge from 1 coulomb from one point to another. So let's move on, and the question number 3 is how to maintain continuous flow of electrons. We have seen that we can move electrons from one point to another using potential difference or voltage, but how do we maintain that flow? Let's check that out. So here we have a flask filled with a solution called H2SO4. It is also called as electrolyte. In H2SO4 we have placed a copper rod as an anode and a zinc rod as a cathode. Now once we have placed this rod in the solution, a chemical action takes place. This chemical action takes the electrons from copper plate and transfers it to zinc rod via the solution. And as we have seen in our previous video of the series, removal of electron from an atom makes it positively charged and addition makes it negatively charged. And hence copper rod is now positively charged, say positive Q coulomb, and zinc rod is negative charged, say negative Q coulomb. This chemical action has done some work to do so, say W joules. And hence the potential difference between these two rods would be W by Q volts. As we are successful in creating potential difference between these two plates, now it is obvious that electrons will now flow from zinc rod to copper rod. We only need to connect these two rods with wires. And this flow of electrons through wire is what we call electric current. Once all the electrons are transferred, the chemical reaction will again take place and will transfer equal amount of electrons from copper rod to zinc rod via the solution to maintain the original potential difference. Again, the electrons will move from zinc rod to copper through wire. Again, the chemical action takes place to maintain the potential difference. This process will keep on repeating till the circuit is complete or till there is a chemical energy present. And a device which is successful in maintaining the potential difference is set to develop the electromotive force, or EMF in short. Let's read that again. A device which is successful in maintaining the potential difference is set to develop the electromotive force. So we have arrived to a very important conclusion. Potential difference causes electrons to flow while EMF maintains the potential difference. So our question was how to maintain continuous flow of electrons, and the answer is electromotive force, or EMF in short. Now you may ask, this chemical reaction is the only way to create EMF? I'll say no. There are several ways to create the EMF. One we just saw, using chemical reaction or batteries. You can also do it by using solar cells or generators. These are the few ways of creating EMF. Now it is obvious to get confused between voltage and EMF. If you have any confusion between these two, you can watch my detailed video on difference between potential difference or voltage and EMF. You'll get link for that video down in the description. I hope this video helped you in understanding the meaning of voltage. If you like the video, do share it with your friends. If you would like to watch previous video of this series, you will get link for that video down in the description. That's all for this video, guys. I'll see you in my next one. But till then, keep watching, keep learning.